I'm always on the lookout for clever tools to make repairing vintage computers a bit more straightforward. Not too easy though, or the videos would be a bit boring. Multimeters, oscilloscopes, diagnostic cartridges and RAM testers all play their part in getting a broken machine back to a working state. One of the most useful, the DRAM tester, is also one of the least trusted. And if I'm honest, I can understand why this is. DRAM chips can fail in dozens of ways, and it's really difficult to test for every type of failure. Add to this, most modern testers use CMOS technology, while these vintage chips rely on older NMOS hardware. They essentially speak different electrical dialects. For instance, an old RAM chip might say, "I'm a logic high at just 2.2 volts, but a modern CMOS tester is waiting for at least 3.5 volts before it agrees. That grey area is exactly where you get the false positives and ghost errors that make us trust these testers less than we'd like to. The alternative to a dedicated chip tester is to put a suspected faulty chip into a working machine such as a handy Commodore 64 and run through software diagnostics such as the brilliant Matt Desmond's DesTest switch, which will put the memory through a suite of tests and sniff out anything untoward. The problem with this method is it's possible to damage your system if a chip is broken in certain ways. Again, this is unlikely and not something I've seen myself so far, but it is possible. A good example would be the 4116 lower RAM chips in a 16 or 48K ZX Spectrum. These require 12 volts, -5 volts and +5 volts. In this case, if the -5 volt rail was internally shorted in the broken IC, that could theoretically pull down that rail to ground for the rest of the lower RAM bank. If that happened and you left that machine switched on for a short time, the voltage bias in those chips would be wildly out of whack and probably result in all of those chips destroying themselves in a blaze of magic smoke, taking the Spectrum's fragile DC-DC circuit out with them. It would also be theoretically possible for the 12 volt rail to be shorted to one of the data or address lines, sending spicy voltage into parts of the system not designed to cope with it. So, whilst using a precious vintage computer as a RAM tester is the gold standard in testing a working chip, it also carries a slight risk if that chip is seriously faulty. For me, this is where a chip tester comes in. I want it to find the really broken chips with internal shorts that could spell doom for my precious vintage hardware. And for much of the life of this channel, I've relied on this tester here. This is a so-called 1-bit DRAM tester, which I bought a few years ago on eBay. This one's been around for a while now. It's reasonably good value and I've recommended it to many people over the time I've used it. It works well. The interface is a little basic, but it does a decent job of telling you if a chip is good or bad using just 4 coloured LEDs. There is a newer version that supports even more chips than this one too. I also have my amazing Retro Chip Tester Pro, kindly donated by Jacek from American Retro and Stefan from the 8-Bit Museum. This tester is like a big Swiss Army knife for retro repair. Not only can it test DRAM and SRAM memory, it can also test a multitude of different types of chips, from ROMs, PROMs and EPROMs to literally hundreds of different logic chips. I reach for this when things get serious or I just need to test something obscure. The sheer size of this device is what stops me from reaching for it during fast-moving repairs, but it remains a favourite in this workshop. It's all very well working on something safe and plentiful like my beloved ZX Spectrum or Commodore 64. There are literally millions of these things being dug out of sheds and attics all the time. But what if you want to explore something a bit more obscure? Buying a rare vintage computer like a Computer's Lynx these days is a huge investment. But there is another way. Which brings me to the sponsor of today's video, PCBWay. Thanks to the amazing retro community, enthusiasts are actively reverse engineering these incredibly rare machines. So instead of hunting down an expensive fragile original, you can take those open source files, upload them to PCBWay and have a brand new professional quality replica manufactured. Take these Computers Lynx PCBs I was generously donated. PCBWay makes bringing a forgotten system like this back from the dead completely accessible. And if you're building smaller expansion cards, parts, memory modules or custom adapters to get these obscure systems running on modern displays, they can fabricate standard boards up to 100 by 100 millimeters for just $5 for a batch of 10. They can even 3D print missing keycaps or CNC machine custom cases to finish the build. Don't let rare hardware become a lost piece of history. Check out the link in the description to get your custom boards and parts made. Big thanks to PCBWay for supporting the channel. And to Lester for sending me these. More recently, I made a video about this device, the Pico DRAM Tester by TubeTime. This is a promising open source project, and Aki from the Retro Hardware Discord has taken to making big improvements to its firmware. I've had mixed results with this one, and whilst it supports a wide range of RAM types, I find myself not trusting it as much as maybe I should. I know there are plenty that speak very highly of it though, and if you would like to know more, I made a video about this one a little while ago. I now have two new devices in my workshop for testing RAM chips. Both of the creators randomly contacted me on the very same day and offered to send them over. This one is made by Andreas, who goes by the name Tops4U on GitHub. I will look at this open source Arduino based tester in a future video, but for this episode I want to look at this device called the Multi Retro DRAM Tester, which was kindly sent to me by its creator Phil. This one is not open source, and once you see the feature set and how much work Phil put into creating a pro-level diagnostic tool, I think you'll understand why. Here are some of the headline features of this tester. A resettable fuse and high-speed fault detection system that can auto-power off the device within 100 microseconds if a short is detected. It's surprisingly easy to kill a tester with a dead short, and this prevents that from happening. Built-in multi-voltage support for chips like the delicate 4116, for me a super handy addition considering the machines I repair. Dual microcontroller architecture. This has an RP2040 and a RISC-V processor that Phil added to handle some extra features. Fancy. Comprehensive pattern testing using sophisticated algorithms like March-C and Checkerboard. High Z or Z leakage detection pre-test with 10K pull-up and pull-down resistors to catch electrically weak chips that can pass standard tests. And Python-based PC software that provides real-time bidirectional control, allowing you to monitor tests on your PC screen. There's a lot to this tester, and I'll try to cover the important stuff in this video. For clarity, Phil kindly sent this to me for free, with no requirements to make a review or have any control over the content of this video, although he is helping me with some of the more technical stuff. And upon receiving the tester, the first thing I did was grab my box of broken chips, pick out all the different RAM chips, and then sort them into the different types. Over here on the left are just a few 4464s. These are 4-bit by 64K, often found in later Commodore 64 shortboards. Next in these three columns, the best represented chip here is the 4164, a 1-bit by 64K, most commonly found in the longboard C64s. I couldn't tell you how many C64s I've repaired compared to ZX Spectrums, but it's quite interesting seeing how many of these chips are here. The next four columns are all upper memory chips from ZX Spectrum 48Ks. This first section are TI4532-NL3, and the next is TI4532-NL4. These are the exact same chip but with different bad halves. There are also three Oki 3732s over here. Oki are pretty reliable. I should quickly explain this bad half thing for those that don't know just how cheap Clive Sinclair was. In order to meet his incredibly low price point for the 48K ZX Spectrum, Sir Clive chose to use 64K 1-bit RAM chips with a bad half. Now, in order for these to work in each ZX Spectrum, the board has a range of jumper wires to connect the addressing up to accommodate the different types of bad chip. They could be bad in the top or bottom half, as these TI chips are, or they could be bad in the left or right half, as these Oki chips are. To give Clive credit, it saved a bunch of money and made a reasonably capable machine accessible for many more families in the early 1980s. And finally, a bunch of good old 4116 lower RAM ZX Spectrum chips. These were used in all kinds of machines back in the day, but all of these ones were taken out of faulty Spectrums. Now, one thing surprised me here, and no, it's not the 4164 I just noticed in the wrong place. What really surprised me was how many MT branded 4164 chips there are in this selection. MT have a terrible reputation for faulty chips from this era. It's almost become a meme by this stage. But a quick head count shows just 8 in the 4164 and 4464 sections. In the same category, there are 16 Texas Instruments chips. I'll be less hasty to condemn an MT chip in the future. With all the chips sorted, I began testing each one to see what kind of faults would be detected. I discarded many of the chips as uninteresting, but there are a few here worth showing again. For testing, I have my original multi-DRAM tester that Phil sent me. I also have another couple here that are based on the new revision of this tester with a few hardware changes, but nothing that will make any difference to the testing, so I'm going to stick with the one I have configured how I like it. I also have my old 1-bit tester. This can do 4116 chips and 4164s, along with a few variants. And finally, I have my Pico DRAM tester running a brand new beta firmware that Aki from the Retro Hardware Discord just released today. Oh, as well as the dedicated testers, I have this 48K Spectrum motherboard with a Steam Card Pro plugged in for the final say in testing. So here we go. I found a bunch of 4116 in my bad chip pile which tested good in the new tester. But as you can see in the old 1-bit tester, this immediately fails. In the Pico tester it passes. Like I said, in the Multi-DRAM tester it also passes. And in the ZX Spectrum, running the Smith & Alford diagnostics, it passes too. A few of these did exactly the same thing, and I've sent a couple off to Phil for further testing. Now, these chips here have already featured on my channel. These are 4532-NL4 upper memory chips from a ZX Spectrum that really had me scratching my head. So something on one of the lower RAM chips has failed. With these in the original motherboard, the diagnostic software was reporting a lower RAM error. 5.5K, right, and the next two are the ones on the problem lines. It took me a while to track them down, but once I did, I placed them in the various testers, which again made me scratch my head. Let's see if that's gone. Yeah, this one's tested slightly different to that one. This one is got 2 green on the bottom and 2 red on the top. In the multi-DRAM tester, these fail reporting high Z with the data pin 14 stuck low, which is basically what I tracked down in that ZX Spectrum repair video. In the 1-bit tester, these chips pass. 2 green lights indicate that half the chip is good, in this case the bottom half, which is completely normal for a 4532-NL4. In the Pico DRAM tester, setting the test to match this type of chip, the tester again misses that this chip is faulty. Unfortunately, my test machine here is fitted with Oki chips, which are also half bad chips, but these are either half bad left or right rather than up or down. So without replacing all of the chips and setting the jumpers to match the 4532-NL4 chips, I can't test this one in the ZX Spectrum. But if you want to see them in a board being tested, you can go and watch my original repair video. Another important feature of testing chips, at least for me, is speed. I will pit all of these testers against each other in a race to pass this known good 4164 chip. Bear in mind that the multi-DRAM tester is set to its most extreme testing suite. In this case, it's testing March B, then March C mix, then checkerboard, and then random data. Oh, and then row retention. It also does some pre-test checks. I'm sure the other testers are doing multiple tests too, but none of those let you choose which ones. Here we go. 3, 2, 1, go. And in just 3 seconds, the multi-DRAM tester is done with its extensive suite of tests. The Tops for You tester is also super speedy at 4 seconds. The Pico DRAM tester comes in a respectable third at 6 seconds. And then we have to wait around a bit for the 1-bit tester to finish in 13 seconds. That doesn't sound a lot, and it really isn't. But it starts to add up if you have 32 or 64 chips to test. Now, one of the things I really like about the multi-DRAM tester is that it tells you exactly what it found. Looking at some of these bad chips, you can see a range of different errors, with March tests failing and shorted pins in different places. Things like this can really help you make sense of how a faulty chip was affecting your machine. It was actually fun going through the faulty chip bin and seeing all the different ways they'd failed. Lots of shorted chips in there. Also, it was fun to find a handful of fully working chips. I've no idea how that happened, but they all checked out fine in all of the testers. One big weakness of my original 1-bit tester is the limited type of chips it is able to test. There is a newer version that has a third socket built in to allow it to test larger 18 and 20 pin chips. The Multi-DRAM tester is even able to handle 2114 SRAM chips if placed in the socket upside down or the wrong way around. Rotated 180 degrees might be a better way to describe it. Probably the most comprehensive tester here in terms of types of chip covered is the Retro Chip Tester Pro, which I've not featured as much in this video so far, purely because of the same reason. I'm less likely to reach for it during repairs. It's a great device and can test lots of other types of chips as well as DRAM and SRAM, but being comprehensive, it has a certain amount of bulk and complication that makes me reach for a more simple tester first. And for a very long time, that has been the 1-bit tester. Even whilst I've had the Pico DRAM tester, I still reach for the 1-bit tester first because it's just quick and easy. But now I have a new favourite, and that's not all this can do. Plugging the USB cable into a USB port on your PC and opening up the software I downloaded from Phil's multidramtester.co.uk website gives you an on-screen interface. This is pretty handy for YouTube types like myself and gives me a much nicer way of presenting the info on this tiny screen. This not only gives you easy to use on-screen controls, but also shows even more information on the type of fault detected. I really like this and I'll be using it quite a bit in future videos. Phil is actively updating this device's firmware all the time, and he's hinted at a future use for this connector over here that I promised I would not tell anyone about, and it would make no logical sense for me to break that promise. I really like this device. It's easy to use, it seems to do a difficult task very reliably, and it doesn't cost the earth to buy. Out of all the testers I've personally used, this one is head and shoulders above all the others, especially for my own use case. I haven't shown much of the other tester I was sent in this video by Tops4U Andreas, as it's a slightly different, more simple proposition than the multi-DRAM tester, but it might also be of interest to some of you out there that prefer to make your own devices. This one is fully open source, and I'll leave a link to this as well as where you can buy the multi-DRAM tester in the description. Thank you for watching. I hope you found that useful. I'll see you in the next one. So many testers.